give it a second for everyone to join on in. All right. One more minute and we can go ahead and get started. All right, let's go ahead and get started then. So, today we're basically just going to continue with where we left off. We're working with our Code Wars kata, and we're basically using this as a way to work on our problem-solving skills, as well as learning about some new functions and some new methods. So just from yesterday, I learned we worked with two different functions. We worked with the ABS function and the sum function, and we worked with three different string methods. We worked with .replace, .count, and .join. So we learned quite a lot just from yesterday's session. So basically, we're just going to continue where we left off. So I'm going to head over to a practice, and I think we left off at a level 7. So we'll just continue there, and we'll go most popular. So we did vowel counts. Let's see if I can find something interesting that we can do. Descending order. This seems interesting. Your task is to make a function that can take any non-negative integer as an argument and return it with its digits in descending order. Essentially, rearrange the digits to create the highest possible number. Okay. Let's do this. This one seems interesting. So we're being given a number, right? And our job is to take each of these digits and just sort them by highest all the way to lowest. And if you put that into its own number, then you get the biggest number you can create. This is really similar to one that we did yesterday. I don't really remember the name of it, though. So what we're going to do is we're going to make a list of the digits, right? And to do that, we're going to go for every digit in the string version of the number, because, again, we want to go through each digit to turn the whole thing into a string. So for each digit, we're going to add that to our digits list, right? So now we have everything in that order. And what I'm actually going to go ahead and do is also turn that into an integer. I'm going to turn that digit back into an integer when we add it back, because, again, we have to sort the whole thing. And this is actually going to bring us into a new function we're going to learn about. So I'll leave these up here. These are the ones we touched in our first session. We can look at another function called the sort function. It's the sorted function. So I'll give you guys an example. Let's say we have an unsorted list. Unsorted list. And this will just be 1, 7, 5, 3, 7, 9, 0. Okay? We want this to go 0, 1, 1, like from lowest to highest. So what we want is we want something like this. We want 0, then 1, then 3, then 5, then 7, then 9. We're going from our lowest to our highest. Okay? So we're going to create a new list. It's going to be our sorted list. And that's going to be equal to our sorted. We're going to pass in an unsorted list. If I run this and I print out our sorted list, let's see what we get. we go. So we get 0, 1, 3, 5, 7, 9. So basically what this sorted function does is it's actually very flexible. So I can give it either a list of integers or I can give it a list of strings, and it'll find the best way to sort of sort them. So numbers like integers, it'll just go from lowest to highest. With strings, what it might do is do like the highest number in the alphabet. Like if it's an A, the A's will come first, and it takes some time to work around with, but it's pretty flexible. And another thing, let's say we want this in reverse. We want 9, 7, 5, 3, 1, 0, which is what we're working with right here. Then we can pass in reverse is equal to true because we're just reversing this list. So if we run this now, the list gets reversed. So let's use that whole principle with what we have so far. So we have all of the digits, right, in their integer form, which makes them a lot easier to sort. So we'll say sorted digits is equal to sorted digits. And again, we want it from highest to lowest. We're going to set that reverse to be equal to true, right? And then what we're going to do is, if you remember our dot join function, let's see if that works. So I'm going to have my sorted list. Let's see if we can join it into a big number. We're going to print the dot join of our sorted list. So we need to make sure these are all strings now. Okay. So basically, let's go back over what I've done here. I've gone through all the digits in my number, right? All the digits one by one, and I put them into this digits list as integers. I've then gone ahead and I've sorted out our list of digits. So now they're in order: 9, 7, 5, 3, 1, like that. What we now need to do is put them all together, combine them. So now this is going to be another new function that we're going to work with, and this is going to be our map function. Our map function. So this is also pretty awesome. So again, let me set the stage for this function a little bit. We've taken all of our digits, right? So let me just comment out a bunch of scenarios. So let's say our number that we're given is 1, 5, 7, 9, 3, 2. Okay, that's the number we're given. We've gone ahead and we've gone through, and as a string, we've gone through each digit and we added it to our digits list as an integer. Our digits list should now look like 1, 5, 7, 9, 3, 2, right? Because again, each of the digits, and again, these are all integers. Then I've gone ahead and I've sorted it all out. So now this sorted digits list should look something like this. It should be 9, 7, 5, 3, 2, 1, right? The only issue is I want to join them all together, right? Put them into one big string and then convert that into an integer. But I can't do that since these are all still integers. I need to convert them into strings. Now, what we could do here is we could have a for loop that goes over all of this and, converts it back into a string, adds it to a variable. We could do that. That's totally doable. But there's another interesting thing that we can do. So this map function basically takes an iterable, right, like a list, and for basically each of the items in that list, it applies a function to it. So again, let me give you guys an example. So again, our sorted list, right, these are all integers in here. So what I'm going to do is I'm going to create another list. I'm going to call it sorted list strings. And again, basically all the items in this list will be strings. I'm going to map my str function to my sorted list. So let's see what that gives us if I print sorted list string out. Let me put a list function around that. Oops. List, there we go. So now our sorted list was all integers, and now in basically one line of code, we've converted the whole thing into a list of strings. We haven't had to go through a for loop to do the whole thing. We just used our map function and our list function. So what's going on here? Basically, what I'm telling Python is, hey, Python, I want you to basically map my str function, right? What does our str function do? It converts things into strings. I want you to map this function to all of the items in my sorted list. So basically what it's doing is it's saying here, this is going to be a new list, right? And we're going to go through for item in our sorted list, we're going to add the str of that item to our new list. That's what this map function is basically doing. It's doing this. It's going through each item and applying this str function on it. Finally, I'm putting this list function around it because you note that if I leave that list function out, I get a map object, right? So this gives me an object, so I need to convert it back into a list. It's a little confusing. It's a little tricky. Again, you'll get the handle of how these functions work as we continue. So we have another list. We'll call it sorted string digits, if you will. That's going to be the list of the map object when we map the str function to our sorted digits. So what this is going to give us now is it's going to say sorted string digits, and it's going to give us from this. It's going to give us everything as a string now. So these are all strings instead of being integers. And now what I can do is I can just return them all joined together into one big number, sorted string digits. That's going to give me all of them combined into a whole big number as a string. But again, we want to have an integer, so I'll put the int function around that. If I test this out, it works just fine. I'll attempt it. Boom. We passed this one. So how do we feel about this one, folks? Thoughts? You guys want me to go back over it? Just make sure my chat is all good. All right. I'm not seeing any questions. Okay. I'm just going to run through this line by line one more time, just in case anyone watching the recording later is confused. Okay. So in this, problem, we want to take an integer and basically return it with its digits going in a descending order. So the highest digit to the lowest digit. So again, if I have 157,932, what I want to return is 975,321. I'll go highest to lowest, and I want that as an integer. So the first thing I'm going to do is I'm going to go ahead and take this number, convert it into a string, and go through each digit in that. I'm going to take that digit, its integer value, and I'm going to add it to a list called digits. So now I'm going to have a list that looks something like this. And again, you'll notice that all these numbers are in the same place that they were in our original number. So now what we're going to go ahead and do is use our sorted function to take these digits and sort them from highest to lowest. So we had 1579321. Now we have 975,321. Okay? In order to combine it, right, put them into one big string, we have to make them each strings themselves. They can't just be integers. So we're going to use our map function to apply our string function to each of these items. So now we're left with something like this. And now we're going to go ahead and combine this. Since they're all strings now, we can combine it into a whole big number and then convert that big number into an integer. Bingo, bango, bongo. We've solved the kata. A little confusing, but again, this is not the first time, or sorry, this is not the last time we're going to be using these functions. They're pretty like handy with these sorts of problems. Okay, so I'm gonna go ahead and submit this. So that is done and submitted. You see people have used something very similar to this. They're sorting it, right? They're using that sorted function. Again, I'm trying to keep it as readable as possible for what we know. It's pretty interesting what people have done. Always nice to look through them, get some ideas of how the things look. So let's head over back to our practice tab. We'll do a level 7. Give me 1 second. So let's find another level 7 that seems interesting. So we'll look for the most popular ones. Let's see. Which looks interesting. Anything catch y'all's eyes? Get the middle character. That seems nice. List filtering. Let's look at this one. With the strings filtered out. We'll save that one for later. What's this? Get the middle character. You're going to be given a word. Your job is to return the middle character of the word. If the word's length is odd, what's the mumbling about? Let's look at that one. Mumbling. This time, no story, no theory. This examples below show you how to write the function accum. Okay, let's read this. So basically, it looks like what you're doing is you're taking each letter. Oh, okay. I see what's going on here. I'm trying to think if this is good for us. Let's try it. What's there to lose? We'll learn something new anyway. Let's just go for it. So let's try to identify a trend, because this is different. We haven't really given any parameters or rules. We're sort of asked to figure it out ourselves. So it looks like, let's try to draw some connections between our input and our output. So if I'm given A, B, C, D, I get A, B, B, C, 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 D, 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 D. Now, what I'm noticing is A is the first letter, and this A section is only 1 character long. B is the second letter. This B section is 2 characters long. C is the third letter, and this C section is 3 characters long. So the length of a section is equivalent to a character's sort of position in the given text. They're all combined with these dashes, so I'm thinking using the dot join function with the dash. So that's what I'm thinking. And again, your first character in each section is always in uppercase, and the rest are lowercase. So let's try this. Any ideas of how we might want to approach this? The dot join is definitely something that we're going to use later on at the end when we combine all these sections together. I think we're going to have to use another function. Okay. So we're going to learn about another function. That means in a 30-minute span, we learn about another function that's called the enumerate function. Again, if a lot of these functions aren't really clicking right now, don't worry. We will get a lot of practice with these. So Eventually, you'll start using them a lot more frequently, and you'll get pretty used to them. So let me talk about this enumerate function before we start working on this one. So basically, let's say we have a list, right? We'll just call this names. Put our student names in here. That's 2 Marias. All right, get some names in there. So there's 2 ways that we know of how to iterate over a list, right? I can say, let's make this names. I can say for name in names, print name. Right, and that'll give me all of their names. Pretty straightforward. The way we first learned with was that our range function. So for I in range in the length of our names, we're going to print names at the index of I. Same thing, right? They both do the same exact thing. But what's different? So for this one, we get the name, the object directly, right? We don't have to use an index or anything like that. With this, we're using our indexing. Now, the reason I'm bringing that up is what if there was some way to combine it? Where in a for loop, you could get its index and the object itself. The reason I'm saying that is if you look at this, A has an index of 0. How many lowercase a's do you see here? 0. B has an index of 1. How many lowercase b's do you see here? 1. C has an index of 2. How many lowercase c's do you see here? 2. And you guys can sort of probably identify the pattern I'm noticing here. So the number of lowercase letters in a section is equal to the character's index. So again, let's check with this example right here. Our y has an index of 0, 1, 2, 3, 4, 5, 6. So we're hoping that has 6 lowercase y's, and that's what it has. 1, 2, 3, 4, 5, 6. Okay? So I'm going to show you something really, really cool. Again, we want to combine our ability to get our index and our object directly. So what if I said for index name in enumerate names, print index name. Now I'm going to go ahead and comment those out. So this enumerate function has allowed me to pull both an index and a name. Okay, so again, Maria, your name is at index 0. Luke, his name is at index 1. My name is at index 2. And we're able to access these things just from our for loop alone. And you might notice this is very similar to our dictionaries. So let me pull up let me just make a sample dictionary, and I'll just make it scores, okay? And again, you don't have to follow along with this section because this is just for the show. Let's say I have 100. Maria has 100. Let's just say everyone has 100. What was the name of the dictionary method that we used to print out both the key and value? It was dot values, right? And this allowed us to say print key and value. So this is very similar to that. Oops, there we go. It's very similar to this. So does this enumerate function make sense so far? It basically allows you to pull the index and the name. The index is the first thing you can pull. The name is the second thing you can pull. How are we feeling with that? Cool? Awesome. Let's use it with what we know. So let's actually bring this into our REPL because I don't really like this coding environment. I don't like the color. We'll just use this to help guide us. So let's come down here. This is what we want to accomplish. I'm going to create a function called accum. All right, and it's going to take, what's the argument called? It's called s, okay? What we need to do is we need to look, it's a string, right? So the first thing we're going to do is for every character in S, we're going to print that character out. Okay? So if I call, there's a QM function down here. And again, let me comment this out as well since we don't want it to. Okay, so we're getting all of the characters. Cool. The first thing we need to do is let's build in our enumerate function, right? So for index character and enumerate S, let's see what this gets us. Index and character. A is 0, B is 1, C is 2, D is 3. Now, if you guys remember, the number of lowercase letters is equal to the index of the character. So again, let's just print out character times index. You'll see what I'm doing here. Again, we have 0 A's, 1 B, 2 C's, 3 D's. Okay? Now what we need to do is implement our uppercase, right? How do we do that? Well, we have another string method, dot upper. Dot upper. And what this will do is if I have, say I do that, right? I'm going to just print out each of the characters in their uppercase form. Boom. Dot upper is what I add on. And if I want them in lowercase, I say dot lower. Boom. So our whole message, okay? Because again, our whole, like, we'll call each of these messages, each of these little sections, we'll just call this section. Make it a whole big string. Okay? The first character in your little section is always the character in its uppercase format. Character.upper, right? And then after it, you're going to have your character in its lowercase format times the index. That makes sense. So if I go ahead and I print out this section, you should hope to see, boom. How do we feel about this? Is it confusing? Is it making sense? Okay, you think it makes sense? I'll just go over it one more time, just to minimize any doubt or anything. So again, we're enumerating our string. So what's that going to allow us to do? It's going to allow us to pull the index as well as the character, right? So we're getting the index. So I'm getting the A and I'm getting the index of 0. Now the pattern we identified was that the amount of lowercase letters is equal to the object's index, right? So I have that index. What I can do is I can take that character and I put it in lowercase. And again, remember that whole string thing where if you take a string, you can multiply it, you get that string however many times it's there. And then in front of it, we're going to put the character in its uppercase format. And then we're going to print each of these sections out. So what I'm going to do is I'm going to have a list. I'm going to call this message, right? The whole message, if you will. Make this an empty list. And for each of these sections, I'm going to add it on to my message, .append section. Now if I come down here and I print out the whole message, the list, like that. All we need to do now is just join them together with these dashes between them. So we can use our .join, boom, boom, do that, and we get our desired output. And again, since this is code wars, we have to return everything. So we're just going to put return. I'll copy this, boom, paste this here, boom. Let's test it out. It works. All of our basic tests pass. Let's attempt it. Cool. The only part that could really get confusing is just this section, because it's kind of a confusing string to look at. Just realize this is that uppercase character, and then this right here is the lowercase character times the index. So that's the amount of times that it's going to appear. So let's go ahead and submit this. Let's take a brief look at some of the people's other answers. So yeah, these people are doing something very similar. So we have C dot upper, C dot lower, and they're multiplying it by the index. And again, they're using the enumerate as well. So it works well. People are obviously using some principles that we haven't touched upon yet. Our code, honestly, in my opinion, looks more readable, but they all do the same sort of thing. Cool. It's 12:30. So let's do one more 7, and I think we'll call it for today's review lesson. So again, I'm gonna sort by most popular. You guys let me know which one catches y'all's eyes, or which one you think looks interesting. So we did the mumbling one. That's the one we just did. Okay. Get the middle character. That's strings. Yeah, let's do some string stuff, right? Let's try this then. So you get the middle character. You're going to be given a word. Your job is to return the middle character of the word. If the word's length is odd, return the middle character. If the word's length is even, return the middle 2 characters. Okay. So again, test is 4 long, right? It's 4 characters. So you're going to return the middle 2. Testing is 3, 6, 7 characters long. So we're going to return the middle one, which is just that T. Cool. Let's do this. Let's train on this one. And again, let me post this link into chat. Okay. So let's try to find a pattern here. Okay, because that's really what this is all about, finding the pattern. So let's use this testing as our example. Let's look at this in terms of indices, right? 0, 1, 2, 3, 4, 5, 6. So when I take the length of this, right? When I do here, let's copy this, and we're going to use this into our code. Again, I really love coding in REPL. This is our test case, right? So let's work with this. If I print out the length of the string testing, right, I get 7. So I know that it's odd. The indices are going to go from 0, 1, 2, 3, 4, 5, 6, right? So when the object, or sorry, when the string has an odd length, right? Its highest index is 1 minus that, right? Because 6 is just 7 minus 1. And then if I take this 6 and then I divide it by 2, I get the middle index, which is that 3, if that makes sense. So again, what I'm doing is, let's say we just have test string, and let's call this testing. I'm going to print out the length of this test string, right? And it's 7. Okay. Now, if I do, let me pull up the pattern thing again. So again, to get the highest index, I'm going to do, we just want the middle thing. So it's going to be the length of the test string minus 1. And then we're just going to divide this whole thing by 2. And if I do that, oops, I also have to make this an integer. Ooh, I confused myself. This is confusing code. There we go. So we put int on here. Oof, I've confused myself. Okay. Restart. Okay. We have our test string. I'm going to make another variable called test string length, right? And this is going to be the length of our test string, which in this case is 7, right? And again, we want to get t. This t right here is our desired output. So what we've identified as our pattern is we're going to, since it's odd, we're going to take our length, 7, and we're going to subtract 1. The reason we're subtracting 1 is that this last character, G, has an index of 6, right? It's the highest index that we have. So we get 6, and if we divide that by 2, right, cut it halfway, then we get the desired index of 3. Okay? So again, we're going to say test string length, and we're going to say highest index is equal to test string length minus 1. And then we're going to say middle index is equal to highest index divided by 2. And I'm going to turn this into an integer. Because again, when you divide, it turns into a float. And again, our indices can only be integers. So then if I print out test string with our middle index, I get that t. So one more time, what am I doing? I have a test string called testing. It is 7 characters long. Since it's 7 characters long, my highest index is 6. And if I want to cut it in half, I can just divide that index by 2, so that I'm getting 3. That 3 is 0, 1, 2, 3. There we go. So that's how we're approaching it when it's odd. Now we need to look at this for when it's even. So let's use this example right here to help guide us. Oop. Let me comment all this out. It's on this. So let's try to see if we can apply our same general logic that we used with the first one. So my test string is now called test. If I get the length of it, it's going to be 4. If I divide that, or sorry, if I subtract 1 from that, my highest index is 3, which makes sense, right? 0, 1, 2, 3. And then if I divide 3 by 2, I get 1.5. And when I convert 1.5 to an index, because again, 1.5 is a float. If I convert 1.5 to an index, I get 1. Because when you convert to an index and it's a float, it goes down. Okay. So what I can do here is I have, sorry about that. We know that this middle index is going to say 0, 1. So that's that E right here. But we want this E and the S. So what I'm going to go ahead and do is we're going to actually try this. Let's try test string. And okay, so if I pass in my middle index, I get E. But if I also add a stop point, let's say I have the negative version of my middle index, I get ES. So what am I doing here? I'm telling Python, hey, basically what this middle index is telling me is how far the middle 2 characters are from the beginning, if that makes sense. So let me explain. This test string, right? The middle 2 characters are E and S. This E is 1 jump away from the start of my string. So again, 1. Right? If I go from this T to this E, it's a 1 jump. So that's what this part is covering. Now, when I take the negative of that, right, the negative index, I'm basically trying to get this S. I'm going backwards now. This is 1 jump. So I'm basically using my middle index to tell me how far the middle 2 characters are from each side of my string. Okay? And then when I do that, I'm able to pull the middle 2. Let's actually find another example because I feel like this might be a little confusing. So this example is going to use middle, M-I-D-D-L-E, so it's a little bit longer, middle. The length of middle is 1, 2, 3, 4, 5, 6. So again, it's 6. subtract 1 from it, and it's 5. Divide that by 2, I get 2.5, but then I convert that into an integer where it gives me 2. So what this is telling me is that the middle two characters, or sorry, one of the middle two characters is 2 away from the start. So 1, 2. So that's the distance it's covering. The second middle character is also 2 away from the other side. So again, if I try this out, I'll still get dd. So what we can do is first let me check. Does this make sense with you guys? The odd one is pretty easy. The last line. Okay. Jeez, this screw does not go back on. Okay. So with my odd, right? With my odd length string, it was pretty straightforward. So because my middle index just points to my middlemost index, okay? If that makes sense. But what does a middle index mean? A middle index just means how far you are from the start. So again, let me open up this testing right here. All right, this string right here. And we know that in testing, again, it's 7 characters long, so it's odd. We know that the middle index is at 3, right? This t is our middle number. How far is t from the start? It's 1, 2, 3 characters from the start. How far is t from the end of the string? It's 1, 2, 3. So it's perfectly in the middle. Okay? Now, I'm applying that same logic here, but because it's not odd, right? Because there's 2 middle characters, I'm basically splitting this into 2 strings. I have this string and this string. I'm cutting it in half, 3 and 3. And what I'm asking Python to do is say, okay, what character is sort of the rightmost, if you will. So again, my middle index is telling me 2. So this is 1, 2. This D is 1, 2 from the start. That's your first middle character. Your second middle character is the back half of the string. So you want to know how far that is from the end of the string. So it's 1, 2 from the end of the string. So we're using this negative index to help guide that. So you're getting this and this. So when you piece the string back together, the middle section of both of those combined. Kind of hard to visualize, I know. I'm trying to think of a real life example. Basically, what I'm saying is we basically need to find the 2 strings where they both have an equal distance from the start and the end, right? And that's what that's doing for us. This is 2 digits to the right, or sorry, 2 digits to the left, 2 digits to the right. Does that maybe sort of clarify? I know it's confusing. I think so, yeah. That's okay. This whole, again, indexing, I learned, I figured out from our last lesson that indexing was something we need to keep working on. So here, let's go ahead and format this so we can submit it. Again, we can probably just copy all of this. Let me index or indent. Oops. Okay. Again, let's call this string length. Taking the length of this. Okay. String length. Now, again, with both of our odd and our even, this whole thing stays the same. The only thing we need to check is if our string is odd, right? We take the length of it, do the modulus by 2, and if that's 0, then we know it's even. Then we're going to take this section here, S, return this, else we know it's going to be odds, and we can just return S with the middle index. Let's go ahead and test this out. Ooh. Interesting. One of them is not working. It's this one right here. OF. Let's copy that. Let's bring it back and see why it might not work. So OF should return OF, right? Our test string is OF. What is the length of our test string? It's 2. What is our highest index? It's going to be 1. 1 divided by 2 is 1/2, which when turned to an index is 0. So if we print this out, what do we get? We get nothing. Let's get rid of this. We get here. So now we get something. So when you put a negative 0 as your index, it doesn't take you all the way to the end. So this has to stay blank in order for it to work. Interesting. I'm trying to think of like the most elegant way of getting around that. Here, let's do our attempt. Let's see how that goes. Yeah, it's just the 2-letter things that are messing us up. So we can say, okay, so if it's even, and if the middle index is equal to 0, and we return this, but it's blank. Otherwise, return this thing with a negative middle index. Negative middle index. So if we try that, there we go. Again, probably not the best case solution, but it's within the limits of what we know. So if I submit this, let's check out some of the other answers. Yeah, so these are functions that we have not worked with. So there's some good solutions out there. Some of them do look similar to ours, kind of. But look, like things like this where you have a divided by 2 minus 1, that's basically what we're doing here. But I made them separate variables just so it's more easier for us to understand what's happening on each level. Because again, if you just see something like this, it could get a little confusing. But I think that is it. I think we've leveled up. We are now level 7. So yeah, I think that's it for today's review lesson. I do have another lesson scheduled for later today. Unfortunately, I'm just not feeling very good right now. So I think I'm gonna have to cancel that lesson and move it to sometime next week because I am, right? But again, thank you so much for participating. Thank you so much for joining me in today's review lesson. And yes, next week we will continue working on Code Wars because again, I really like Code Wars. It is like so much more fun than just like lecture and just like, whatever. And also it reminds me of what we used to do at the beginning where I used to have like those questions at the end. I always loved that. Because again, it's sort of like a thought process between like the viewer and me. We get to talk it out. So I always find it interesting. So again, before you guys head off and have a good week, quick review, we touched upon our sorted function, our map function, our enumerate function, and our dart upper string method, and our dot lower string method. So literally, in a lesson in one review, we've touched upon 1, 2, 3, 4, 5 functions and 5 new string methods. So that's 10 new things that we've learned. So again, hopefully you get a chance this week to sit down, maybe code, maybe try some of these out, make something cool with them. And yeah, I look forward to seeing you guys for, what's the next one? Lesson 16. I look forward to seeing you guys for lesson 16 on Saturday, September 10th at 12 p.m. Eastern Standard Time. So yeah, as always, take care, be safe, wash your hands, eat well, get good sleep, and I will see you guys next time.